second hour. It didn't take very long. There's a couple of formulas, and they've got a handful of examples. It works out nicely because then tomorrow we can do some combo areas with it, some shaded region stuff, and kind of have a bit of more of a work situation, work problems with it tomorrow. Excuse me. And then kind of go from there. The circle stuff I know we've done. I know that we've all talked about the areas of circles. What was the formula for area of a circle? Pi r squared. Good. So we know that the area of a circle is dependent upon the radius, and we say the area of a circle is pi r squared. Real easy. So if I'm saying just give my radius a value of, I don't know, let's say 4. If I have a radius of 4, what's the area then of the entire circle?
What?
The area of the entire circle. 16 pi. Good. Now remember, when we're talking about areas, we have to have units in it. So I'd say 16 pi something squared. I don't need to press the pi button. We'll leave it in this exact form because it's easy. It's quick. Remember, if you don't have the calculator that leaves it in exact form, just square the radius, write the number down, and put the pi next to it, and you'll be fine. Now, just like we talked about yesterday, remember how we had the circumference was all the way around a circle? If we went halfway around the circle, it was half of the circumference. If we went 90 degrees of the circle, it was a quarter of the circumference, and so on and so on. This is kind of the same thing with sectors. Sectors are just wedges of the circle. Sectors are just wedges of it. They're parts of the circle. So after Miles puts away his phone, when you have a whole circle, if the whole circle has the area of 16 pi, if I cut it in half the circle would be how much? 8. Well, a whole circle is how many degrees? Half of it would be 180. If I cut that in half, I'm at a quarter of it, right? I'm at 90 degrees. The same basic principles we did yesterday. This thing called a sector is just going to be dependent upon, let me write this out, the area of a sector is dependent upon that central angle over 360 times pi r squared. It's a portion of the circle. That portion of the circle is defined by the central angle. Okay? And you wind up with problems exactly like they looked yesterday. The only difference, instead of 2 pi r, it's now pi r squared. You just got to keep which one you're working with, which formula, straight. Remember, I'm not going to make you guys memorize any of these formulas or anything like that. You just have to know which one do you use when. So it shouldn't be so bad. So let's say we have a radius of 4. Let's say the central angle was, let's say that the central angle was 100 degrees, and I want to find the area of that sector. Well, what do you think you have to do? Yeah, it's literally plug and chug, guys. It's yay, man. Again, it's the same thing. It's the exact same thing as you looked at yesterday. You're just pressing a different button. Instead of 2 times pi times r, it's r squared times pi. Everything else works the same. Right? You start throwing that in the calculator. Let's see, 100 over 360 times 16 pi. And I get 40 pi over 9. That's my answer. Something squared. Make this more difficult. Why? Sure. It's fine. Do this one. Same idea. Here's your radius. This one doesn't give you a central angle, it gives you the measure of an arc. Well, if the measure of the arc is 72, what's the central angle? Bing, 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 bing. Dude, put it in your pocket. Put it in your pocket. Put it in your pocket. It's not going to kill you. And just like yesterday, we probably won't get into it today, but remember how yesterday we had arc length, angle, radius? You can be given two of them, solve for the third. You can do the same thing here. If you have area of a sector, central angle, radius, you can work back and forth between any of those two out of the three as well. Bless you. But my guess is we won't touch that till tomorrow, just because there's no reason to push all three of it at the same time. So let's see. What you get? Thank you. There you go. Yep. Don't forget labeling. Areas you got to label. Label, label, label. If you wrote unit squared, would I be mad? No, I'd be happy that you labeled. Sad that you can't really read the letters C and M, but that's okay. You got the U and the N. It's close. A C is kind of like a U. It just fell over. Which one? I think pi is universal, isn't it? Isn't that symbol? Just like the C fell over because it was a U. And I know I don't make my pi the correct way. I think there's supposed to be more of a something like that one, but who has time to write slowly? Okay. Obviously, this is too difficult for you guys today, so. Okay. Let's try something different. Now, sometimes I can say that there's a sector, but instead of worrying about just that, I want to find the area in here. I want to find the area of the snow inside of a snow cone. I know it, I was just harassing you. She hates me. You're welcome. You're very nice, though. Go away. Yeah. Snow on a snow cone. What? You don't believe me? Yeah, or you're just like shaking your head at my randomness of talking to people. Okay, I would too. So, if you look at this one, this was your sector, that whole piece. That was the sector. And what we did is we took the top of it off. So I take the top of it off. What do I back out of the sector? Triangle. You look at it, you have a sector, subtract the triangle to leave the snow on the snow. There's actually a term for that. It's called a segment created, an area created by a segment within a circle. Too many words. Snow on a snow cone. It's easier. You guys have all had a snow cone before, right? Snow cone, obviously it's a cone. It's got a circle top on it, a curve, so it looks like a snow cone. You guys can't visualize that at all, can you? Yes. Would you draw a snow cone differently than that?
Yes.
How? More decorative. Okay, so let's say it's more decorative to make you happy, because I hate when you're sad.
Thank you.
You're welcome.
Okay.
Yeah. Is that more snow coney?
You also gotta decorate the cone.
You're asking way too much. I'll make the cone out of snow.
Can I have it upside down?
Just tilt your head upside down. There you go. Anyway, so what happens here is that you have a sector that you're basically not eating the crust off of a piece of pizza, or you're eating the snow cone wrapper, which is paper, instead of the snow cone ice, which was flavored sugar. So I don't know why you would do that, but let's just say you did. What you're looking at here is that you'd have to figure out the area of a sector, which we know is easy, but then you have to back out the area of a triangle. What's the area of a triangle? Yeah, 1/2 base times height. Well, to be honest with you, if you get into this whole idea of 1/2 base times height with this stuff, it's really difficult, because what happens here is that you don't know what these, all you know is that you have an isosceles triangle. Why is that always going to be an isosceles triangle? Yeah, because the radii are always the same. Now, in order to figure out a base and height here, you'd have to be able to draw an altitude, and you'd have to figure out all this trig stuff. What if I told you there was a better way? You might just believe me. Okay. So if we go back to the idea of a sector. If I mark it like that, that angle is a central angle. Do you agree? Is that then side, angle, side? If I tick mark it just like that?
Yeah.
Okay. So if I draw this through, now we have a triangle then. So there is actually a formula that we use in Algebra 2 for finding the area of a triangle if it's only inside angle side. And it's really, really, really easy. Because you know what the sides are going to be, because you have to have the radius of the circle. Okay. You have to know the central angle in order to figure out what the area of the sector is. So we use those two bits of information to come up with this formula. The area of a triangle, if it's side angle side, is always this. 1/2 side times the sine of the angle. And that sine is the trig function button. Okay? The sine is that trig function button. Which means all you have to be able to do here is make sure your calculator is in degree mode. So I don't think any of you guys, Krishna, you actually check your mode on your calculator? There's a button that says mode. It's kind of nice to have that. If you hit that button that says mode, it should come up with a couple of options in there. It should say radian or rad or degree. Just hit mode, yeah. Okay, make sure it's highlighted underneath degree. Okay, so that's really, as long as you're highlighting degree, you're going to be fine with this stuff, guys. So if let's say that this was radius of 8, we have a central angle of 100, and I want to find the area of the snow on the snow cone. Well, in order to do that, we have a very, very simple problem. The area of the snow is the area of the sector, subtract the area of the triangle. The sector formula, let's try to write these out. Central angle over 360, pi r squared. And then the area of the triangle for side angle side is 1/2. Twice now. Side times the sine of the angle. I would not try to put all of this at once in the calculator. That's the one thing I wouldn't do. I wouldn't, excuse me. I'd figure out the first part, then I'd figure out the second part. See, 108. So we have 100 over 360 8 squared and a pi. And just like yesterday, remember how we used the answer button a bunch of times?
Yeah.
We did the same thing. Let me show you what happens. It doesn't matter which calculator you have. This idea of working them separately is real clean. If I type in this part first, 100 over 360. There we go. Times 8 squared times pi. I get that. I don't care what the decimal is for that right now. All I know is it's 160 pi over 9. Okay. To that, I'm going to have to subtract all the other stuff. Okay. So, excuse me. The other stuff was this. So, I'm going to do this. I'm going to do 0.5 times 8 times 8 times the sine of 100. I get that. Now I have both of my previous answers up there. Okay. What happened?
So she's wrong.
Here's what you do. Yes, sir. Side times sine. Side times sine. I'm sorry, side times side. I can speak, it'd be a lot easier to understand me. Story of my life. Here's what I would do. I would go up twice to highlight the one first answer, hit enter, and then I'm going to hit subtract, answer. And I have both of those values stored, and it should work just fine. Ding, 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 ding. That way you don't have to continually write everything out. Because more often than not, the sector is going to give you answers with pi in it. The other part won't. Because remember how we did sines and cosines and tangents and we got so many decimals over and over and over again? It's going to be the same thing. Over and over and over again. It doesn't change. And you get that. So it looks weird, but is it really all that difficult? No, it shouldn't be. All right, it shouldn't. Try another one. Try this one. Find the snow in the snow cone. Or the snow on top of the snow cone, or to the right of the snow cone. Why do you have to learn I'm just messing around. They all get malaria. Joking. It's actually diphtheria. What? It's not like which part? Okay. So what's made up of the sector? Sector is easy. Angle is how much? What's the radius? Next to where that? 60 over 360. 18 squared. Minus. That's those are super straight. Yeah. And then This is library, that's all I got. So let's see here. With any luck, start out with your sector. That gets you your sector. Throw that in the calculator, what'd you get? You? That's weird. 54 pi? Okay. Now to that, we had to subtract out 1/2 18 times 18 times the sine of 60. Okay? Well, calculator, let's see. 1/2 18 times 18 sine 60. It gives me a decimal. Okay. Now here, I already know that this part's pretty easy for me to retype 54 pi. So I just go 54 pi, subtract my answer. Here's my answer. Maddie, is that better? It's the snow on a snow cone. Why don't you pull your hair back? Because then if there's extra stuff that needs to come out, it'll release out of the one ear. You don't believe me? It's just physics. Last one. Now I'll give you some props. Are you so boring? Oh, that's okay. Come on, guys. We got one last one. I've read that in years. I vaguely remember it. If you guys recall, when we did SOHCAHTOA stuff, remember how we never did anything with, we never did sine or cosine or tangent of 90? Remember how we said we're never going to worry about that angle? This time we kind of have to. When you think about SOHCAHTOA, sine is what over what? Opposite over hypotenuse. So if you're at your 90-degree angle, what's your opposite? Your hypotenuse. So what's hypotenuse divided by hypotenuse no matter what? What's 4 divided by 4? 1. What's shoe divided by shoe? Shoe. Actually, 1. Anything divided by itself is 1. So hypotenuse divided by hypotenuse will always equal 1. That's why the sine of 90 is 1. A little weirdness there. Anyway, so you get what? 90 over 360 is a fourth. 1/4 of 16 is 4. So you got 4 pi for this part. Okay. Next thing we had 16, half of 16 is 8. 8 times 1 is 1. So you have 4 pi minus 8. And then you just press buttons in the calculator. And what do you get for decimal? 456? 57, thank you. That's what we're doing, guys. Okay? The idea here is that we're using this little shortcut of a formula for side angle side only for area of a triangle. It's a nice shortcut because there's no reason for us to have to go through and do all the other extra trick stuff to get to the other parts. It just takes too long. There's no reason. Okay? Plus, now you'll know something new when you get to algebra 2. Yeah. Sorry. I'll get over it. They treat me so meanly. I try to be nice. Do those, please. I know we got a few minutes. I've got a couple of textbooks floating around here somewhere. If you guys want to take pictures of it or go around and see how we go. It should not be such a thing. Otherwise, screenshot what you have on your profile. I think it's 663. All right, you're so excited. Check if it's 663 or 633. I think it's 663. I want to say it's 663. Oh. It is 663. Take a picture of the screenshot. Oh, jeez. Sure. Yeah, maybe, yeah. I think I do. I don't remember off the top of my head. Yeah. Well, this was the yesterday. Yesterday. Even the one from 2 days ago. Oh, wait, you took your name. I'm sorry. Yesterday was the other day. Good morning. How are you? Good to see you. Nice to see you today. I'm glad you're doing well. You all right? No, obviously. Get that answer figured out? What? So that way you get, that way you try to get yourself figured out. Right? Do you guys want to take pictures of this screenshot? You're welcome. Anybody else want anything? You know that? And that's the problem. Right?